Welcome, everyone. Good morning, afternoon, evening, based on wherever you are. Thank you for taking time to attend the third edition of GenAI Bootcamp series. In today's session, we'll be covering key challenges, criteria, and guidelines for moving your GenAI application from prototype to production. I'm Maruti Tumuluri, GenAI specialist, working with a lot of enterprise customers, working in Google Cloud. Before joining Google, I played multiple roles as a developer, lead architect, manager, building compilers, operating systems, cloud platforms, and solutions. And I have with me Adnan Fida. Adnan, please introduce yourself.
Hello, everybody. Adnan Fida. I'm one of the tech leads and GenAI specialists. I work with our customers for their cloud-based solution implementations for AI, data, and applications. Looking forward to sharing some guidance with you today on this topic. Thank you.
Thank you, Adnan. We have a very tightly packed session today. Here's a short list of topics we'll be covering in detail. As you know, GenAI technology is evolving at a rapid pace. We'll be covering some of the important topics and glancing through a few others. Hopefully, we'll be doing a more deep dive sessions, right? Each of these topics really deserves a dedicated session or even more in reality. After this, we also have another session where we walk through building a GenAI application end to end. So with that, let's get started. You may have come across this quote by Chip, I think somewhere early this year, and it's absolutely true, right? Various GenAI models, tools, frameworks have made it very easy for developers to play with technology, build few POCs, experiment, right? However, not all have moved to production. In fact, based on Gartner's report, less than 55% of AI models have actually, and applications have made it from pilot or POC to production. This kind of shows, the kind of complexity involved and the challenges faced. When you look at the challenges, right, basically, there are a few, of course, this is not an exhaustive list, but essentially, starting with data, right, trying to identify the data that drives the models as well as applications, right? Without access to the right data in a timely manner, apps don't work as expected, right? Yes, with GenAI, you don't need as much data to train, right? But then you want to make your responses latest, and Adnan will talk through some of these techniques, right? But you still need data, right? And you still need to interact with the enterprise system. So that's important. And also it's important to kind of make sure you have quality data, right? That's unbiased and all that, right? To make sure you get a truly unbiased opinion. And then model quality, right? Identifying the suitability of the model, right? Over the last couple of years, there's been an explosion of foundational models where, it has made possible for developers to explore these models and use them. However, like not all models are created equal, right? And some have some unique, benefits. And in a way, some of these models have their own, in quotes, personality, right? Like if you give a prompt, you may not get exactly the same answer across, right? So identifying right a foundational model is important, and then identifying performance is important. Again, you might get reasonable performance when you have one endpoint and then respond. But then when you kind of productionize it and when you have hundreds or hopefully thousands or millions of users concurrently accessing the system, right? Making sure you have very less latency and all that is important, as well as accuracy and adaptability, right? We'll go through this. I'll just glance through some of these, but we'll go through these in detail. Another very, very important topic is scale. Yes, you are able to deploy the application. You have an endpoint. You can serve your model or application leveraging that model. But again, when you have globally distributed users, right, whether it is systems themselves or end users, it's very important to use the right infrastructure, right, that can scale, that can cut down a lot of, the management, right, and overhead on that. The other thing is dependency too, right? I think we've mentioned there's an explosion of tools and frameworks. in order to make sure they all work really well coherently, right? So it's important to understand the dependencies. And then no application is production ready unless you have solid operations on it, right? Foundation models keeps changing, data keeps changing, your adapters and tuning will have to accommodate all that, right? So versioning that, managing those changes, having this continuous pipeline is very, very important, and so is observability, right? You want to evaluate your model continuously, you want to evaluate your applications continuously. All that is very, very important. And security and privacy are extremely important, right? They are important for any application for that matter, but for models, given the scope of impact it has, it's extremely important. And finally, explainability and responsibility, right? You want to show the lineage of data, right, that your model or application via the model provides, right? Make sure your data is unbiased or your responses are not unbiased, and then your application is socially responsible. So these are, various phases. It's not so much like a pipeline. We'll talk about pipeline later, but kind of important considerations, right? These phases and patterns are generally towards production based on the problem the application is going to solve, a maturity level of the organization, experience of the team. You may go through various steps, right, and select different approaches. Obviously, each has different effort, cost, and implementation requirements, so you have to think through, right? You've already from previous sessions gone through prompt engineering, right, ranging from single shot, few shots, and so on, and other approaches like tree of thought, graph of thought, and other techniques. You could also use more advanced approaches like RAG, React. Adnan will touch some of these and cover some in detail, right? And external frameworks like extensions, functions. We'll talk about all these in the upcoming slides. You can then tune your models, because again, foundational models are very generic, right? They're trained on massive amounts of generic data, right? Now your application might be targeting a specific domain, focusing on a specific task, right? Then you have to tune your model. And there are multiple approaches. Again, we'll go through the detail. Then reinforcement learning through human feedback, that's important too, right? Putting human in the loop. How do you improve your models and so on? Next, scaling applications, right? Whether it's infrastructure, right? Whether it's CPU, GPU, TPU, that kind of stuff. How do you customize your models? How do you create adapter layers and so on, right? All the time, right? Across this, what we are trying to do is we're trying to improve our models. We are trying to make it accurate. You're trying to make sure they serve well, right? All these aspects. On the operations side and evaluation side, you have ML ops, LLM ops. Some of you who have started journey with AI, right, a couple of years back, might be familiar with ML ops. Some of these investments would continue. Then you have observability, right, and versioning. All these need to be considered. So, and across all these, right, focus on security, privacy, safety attributes, responsible AI, and explainability. So we'll cover all these. With this, I invite Adnan to start presenting and discussing about prompt extensions and LLM tuning. Over to you, Adnan.
Thanks, Maruti, for setting the stage here for me. Folks, here we'll get into some of the ways to extend your prompt engineering and also talk about some of the orchestration considerations. And then finally, when and where and how to do some LLM tuning as well. Before we get into the details, earlier sessions in this series did go into prompt engineering overview, details, best practices. So we have shared some links to those session recordings, so feel free to check them out if you need to catch up. So there are three core concepts and patterns that we'll discuss: embeddings, retrieval augment generation, or RAG for short, and then reasoning and actioning, or REACT. These are the three patterns that address some of the challenges and limitations of LLMs. But before we dive into these concepts, it's important to obviously state what are these limitations that these patterns and concepts help us with. So the three core fundamental limitations of LLMs as they exist today is that LLMs are not being continuously trained. So the information that they have and the knowledge graphs that they have built are always behind in time, and that makes them frozen in time. Second, during their training or any other time, they never had access to your proprietary data. That could be data sitting behind your enterprise firewalls. And that data is essential for your applications to be able to provide the capabilities your users are looking for. Finally, LLMs, again, today have no means or mechanisms to interact with real world, to be able to look up real world information, real-time information, or be able to update other data sources or APIs. So these three limitations come in the way when you are architecting and designing your application for some end user business functionality, perhaps. So to address these limitations, let's talk about some of the options or mechanisms we have available. Embeddings is the first one. And idea here is that human natural language text is converted into numbers or numerical vectors, to be more specific. Computers can't process words, they can process numbers. That's why this encoding or conversion is necessary. So when these embeddings and numerical vectors are created, they're then stored in a database generally referred to as vector databases. There are few around. Google offers a few options for vector embedding databases. There are some open source ones out there as well. But why do we need embeddings? What do we do with them? It's important to understand here. But before I talk about it, you want to think about embedding database. It's kind of similar concept as any app today that would be interacting with the database, either it's relational or of some other shape and form. That app or your GenAI app, in addition to those traditional data sources, will also have access to one or more embedding vector data sources. The value proposition for these embedding vector databases is they allow you to conduct similarity searches. Similarity searches have many use cases. Some of them are very common, such as recommendation engines, anomaly or error detection, being able to look up similar videos, music, things of that sort. In order to conduct those similarity search, vectors or numerical vectors created from embeddings are used. The distance between these vectors is the basic mechanism on how similar search results are returned. And this embedding and vector databases are not unique or new to GenAI. They have been around in AI for some time, and it's very core to some of the Google products that you interact with day to day, such as YouTube, Google Play Store, and other search properties. So now we understand embeddings, vector databases, and similarity searches that they can offer us. But how do we apply that and use them in the context of LLMs? Well, that's where RAG or retrieval augmented generation comes in. When a user provides you an input in the form of a prompt, that prompt, in order to generate a more relevant, accurate response, would need to be augmented by more example, contextual data, additional data points. That augmentation can leverage embeddings, similarity searches. For example, if you're looking for an extraction of some fields from a PDF document, you can look up similar examples in your embeddings and share that with LLM so that it guides them to shape its response accordingly. Now with RAG, excuse me, embeddings is definitely one use case, but they're not restricted to embeddings. They can query any data source, either it's BigQuery, a relational database, data lake of any sort. Idea really is user, when they're adding and providing their prompt, may not have given all the necessary information to LLM. Therefore, we need to augment their prompt by collecting or retrieving information from other data sources, including embeddings. I'll come to RAG and how it's implemented with Google Cloud in a little bit, but we have provided some links to blog that walks you through some of the implementation options as well. And now we have embeddings in RAGs that are providing more context and information to LLMs. But to extend that even further and to address the third limitation, LLMs can also be extended to interact with real world through APIs or through data sources. The request, as it hops around in your application, needs to be orchestrated. And similarly, response also needs orchestration. What are some of those orchestration mechanisms and libraries? Again, we are providing a reference to it. But the core idea here is that by building extensions or leveraging extensions for LLMs in your application can enable LLMs to interact with the real world. For example, a very simple example, if we wanted to look up flight departure information for tomorrow, LLM would not have that information. So when user sends that prompt then needs to be augmented by looking up flight schedules through an API, perhaps. And then that schedule and user prompt is passed over to LLM so it can formulate the proper response. So that notion of being able to look up information, to reason and make decisions, and then take actions by updating certain data sources is what's called as ReAct. So embeddings, RAG, and ReAct, some of the fundamental patterns that will help with your application development to provide the needed functionality. Some examples of the extensions that we have here, just as a reference. For example, when you're building a shopping application for your corporate buyers, you will have to interact with your real-time inventories, pricing, and shipping APIs and data sources in conjunction with interacting with LLM. Similarly, if you're building a QA bot on a certain LLM for your HR employees to be able to ask questions, that application does need to go into various of your other organizational data sources and augment some information for your LLMs to generate those responses. Over time, we do think that extension ecosystems will be evolving, similar idea as apps had about 10, 15 years ago. And we will see internal ecosystems where your organization is building a collection or a gallery of extensions that various teams can use, or publicly, perhaps open source extensions that will be becoming available as well. And Google itself is working on extensions, and in our last cloud conference, Next, we did have a session on our thoughts and our extension framework, and link is provided here. So do check it out. It goes into quite a bit of a detail on how we are thinking about extensions. Just a quick snapshot into what our implementations of these extensions may look like. We will provide collection of first-party and perhaps third-party extensions that will have the same capabilities that are generally available with any cloud service, such as data protection, privacy, compliance, governance, controls. Some of these extensions will also be integrated with tuned LLMs so that these extensions can work well and are optimized. Last but not least, these extensions will then also allow you to integrate your application with other cloud products such as BigQuery and Search. Now, we talked about RAG a little bit earlier. So over here, kind of give you an idea that if you had to do RAG to build a search application using an LLM without any managed service, it's a bit of a process. You'd have to ingest and parse your data or searchable data. You need to chunk it for storage. You need to create embeddings for being able to do similarity searches, do the index for optimization and performance, and have a search engine that can leverage the indexes that you create. And then you also have to then connect it with LLM, so LLM can leverage that search engine. So as you saw, there's quite a bit that goes into building a GenAI search application, if that was the use case. However, if you're looking at Google Vertex platform, it offers or it streamlines your RAG development. And in this example, if you're building a search application, you're simply providing your data, either it's documents or other type of data sources. And we take care of all the intermediate steps all the way up to creating a search engine for you and connecting it to an LLM. You can start querying your search engine within a matter of minutes or hours, depending on the volume of data that you have. So when you're doing RAG, think about open source and other solutions that are out there and take advantage of them. Now, that was about embeddings, RAGs, and Reacts. That was all around prompts and how to enhance or augment your prompts for more relevant and accurate responses. But sometimes, no matter what you do with prompts, it's just not enough. And in cases where instead of providing handful examples from your embeddings or from your other data sources, you have to provide few hundred or few thousand examples to LLM. And that is what we are calling LLM tuning in this context. There are various ways to tune LLMs. However, the two common ones that are emerging are being referred to as adapters and reinforcement learning. Notion behind adapters is simply that instead of using prompts to guide LLM, use hundreds or thousands of examples in a data set that can be used to train an LLM so that it can adapt, it can tailor its responses to your use case on hand. To extend that, reinforcement learning takes that idea but adds a human element to it, meaning not only you're providing LLM few hundred or thousands of prompt examples, but you're also now showing human responses that were generated so that LLM can see how humans are responding to those prompts, and it can try to use the similar feedback. Adapters and reinforcement learning is available today through Google Vertex AI platform. And you train your models by creating one or more tuning jobs through Vertex pipelines. You provide your data, and Vertex is able to create the adapter layers for you. Not only it creates those adapter layers, it will register them and it will serve them in form of endpoints so that you and your users can use them for inference. And all of this infrastructure is managed, meaning you're not provisioning any servers, storage, containers underneath that. And we'll talk more about infrastructure, and Maruti will get into those details. But to close the loop on model tuning here is once your adapter layers are created, they become inline to your request and response loops. And all the requests, when appropriate, will leverage adapter layers, which behind the scenes will communicate with foundational models to generate the response. And with that, we have infrastructure and scale considerations plus model evaluations. And for that, I'll pass it over to Maruti. Thank you.
Hey, thanks, Adnan. Yeah, it's amazing, the way these tools, technologies, frameworks are evolving. Empowering developers to create really, really innovative solutions. Work with a lot of our customers, and it's amazing the kind of creativity that's happening. So it's really great. So okay. So we have done all this, like, you have tuning, adapters, whatever, right? So we had all these things done. Now, obviously, application is not production ready or production worth unless you can host it, right? And that's what we're going to talk about. We're going to talk a little bit about the infrastructure, talk about serving and so on. As Adnan mentioned, right, like it's not just model, right? Or maybe the application. You have to really think about so many things, right? If you're using embeddings, you have to think about the vector databases, right? You have to think about adapters, like, you're doing some fine tuning, then you have to think about compute, all that, right? To tune those models. So infrastructure is going to play a critical part in that. And these are some of the key resources, if you will, or infrastructural requirements, right? Compute, obviously, needless to say, computing is core requirement, right? I mean, this is computing, right? Machine learning, yes, even more. This includes CPUs, GPUs, and Google's TPUs. So think thoroughly and understand, like, the real requirements, right? Often I see, like, we all tend to think like, okay, let me get the best and the biggest GPU, right? Well, it's cool, right? I mean, it's powerful, right? Sometimes you may not have access. Again, there's a lot of competition, right? So I'll talk about some other alternatives, like, be innovative, think about what's the real scale. And also they pay attention to, like, the cost too, right? Because these things are expensive. Now, thinking about data, they're like large models, especially foundational models are humongous, right? And they operate on very large quantity of data. And also you need data and storage to store your, like, whether you're using reinforcement learning or other adapters or tuning, you would need additional data, right, that you want to tune on, right, for your adapters and so on. And you need to host this data. Now, some of them you can use connectors, right, where you can actually use a connector to just ingest data from external sources, but some you need to kind of host. So for that, you could use GCS, BigQuery, or other options like GCS Fuse and persistent disk and so on and so forth. Networking is also important because there's a lot of high bandwidth calls that are happening between various components, and if you have a distributed GPU architecture, right, even then, like, you need that kind of bandwidth. So making sure use best in class networking is important. Obviously, you're running on Google Cloud. We provide that for you by default. And then making sure you have a scalable infrastructure, right? It's not enough. And, obviously that's why you use cloud, right, in the first place, where you want to kind of expand contract based on, customer requirements and demand and so on. And finally, security, right? Security is very important. We have a dedicated section for that later today, right? But, again, this is not an exhaustive list, right? But you really need to think about infrastructure or leverage, platforms like Google Cloud and Vertex AI that provide that infrastructure. From a Google Cloud perspective, we offer, like, the infrastructure and tools and platform, right, across. If you really look at Gen AI space, like, there are three kind of users, right, or personas, if you will, right. So you have foundational model producers, right, who are creating these big foundational models, right, that require massive amount of compute, GPUs, and so on. Then you have foundational model tuners, right, like, who take these foundational models, apply, various tuning on top of it that requires, obviously data, compute, and so on. And then finally, you have consumers, right, who actually use these models and for applications and whatnot, right? So from that perspective, we have entire stack supporting, all these three, right? Starting with our cloud, compute engine, Kubernetes engine, so on and so forth. And then we have open framework, right? That supports a lot of first-party and third-party AML frameworks. And then we have, model as a service, custom ML workflows, and so on and so forth. The other thing is, we do understand, right, and it's been one of our core, pillars is that we want to work with customers and, go where they are, right? And from that perspective, and also I think I mentioned earlier that not every model might suit every purpose, right? So customers want to understand various models, including a lot of third-party models and frameworks, right? So supporting that entire ecosystem is important, and Vertex does, have that support. We'll talk about some of those. Earlier, I mentioned about GPUs, right? Obviously, this is not the latest, right? We have the next generation as well, right? But the idea is, whether you're deploying a large model or running batch production or batch learning or fine tuning, our stack is optimized for workloads, right, in three ways. Firstly, you have scale and speed, right? That's very, very important. And then price and performance and efficiency, these are important too, right? Because you want to make sure you don't, if you're not careful, right, you might kind of get into like runaway spend. So we provide options where you could horizontally scale, right? Just like the how applications used to scale, right? You don't really need to have like a massive single, I don't know, a big GPUs, right? You can leverage TPUs and distribute the learning as well as serving intelligently. So you leverage all these options, right? That way you can not only scale, right, but also keep cost under control. And then talking about like the platform, right? So we have entire portfolio that helps developers build, evaluate. In fact, I should start with evaluate, right? Discover, evaluate, the models, right? Using Model Garden, right, where you can even not only evaluate Google's first-party models, right, PaLM and so on, but also a lot of OSS models as well. And then you have the platform, right, which supports all these frameworks and functions that Adnan just mentioned. Like you have connectors, extensions, you have things like grounding, right, for tracking lineage and so on and so forth. And then you have serving infrastructure, tuning, distillation, evaluation, and so on and so forth. And then on top of it, we have Vertex AI Search, right? You want to build enterprise search kind of an application. I think there was a question around that. So you don't have to reinvent the wheel, right? You don't have to create everything from the scratch. You leverage these applications and build stuff. And then you have conversations, which is basically, chatbot, but, you want to focus on your data and then create these nice chat interactions. And then you have, more higher level solutions like contact center and document AI and so on, right? But the idea is, instead of having, piecemeal approach, right? You have flexibility. If you choose, you can kind of go with the entire stack as a first-party solution from Google Cloud, or you want to like use specific things, right? Specific models or specific frameworks, right? You can do it too. So you have options, right? And the key thing is to think through. I think this slide has been covered multiple times. I'll not go through in detail, right? So it talks about various models we as Google Cloud offer. And then I wanted to kind of touch a little bit on the ecosystem, right? Because ultimately, every customer is unique, every need is unique, every requirement is unique, right? And having capability to use the tool or the framework that best suits the purpose, I think that's the key thing, right? It's very, very important, to leverage whatever skills you have, right? I kind of reflect myself back, right? Like last 20, 25 years, how much technology has evolved. And in last 5 years, it has exploded. And in last 1 year, especially in the Gen AI field, it's been exponential, right? So, having ability to use things that at least you're familiar with, right? And not relearn just because let's say you're using Google Cloud, you don't have to do everything that's Google, right? You can use third party. So just wanted to emphasize that. With that, let me kind of switch over to operations, right? Yes, you have deployed your Gen AI application, you have chosen the right infrastructure, you have considered various requirements, right? Like the regionality, where the customer requests are coming from, the scale, so on and so forth, right? But the other important thing, or in fact, I think I said earlier, When you say production ready, it basically means like, you're able to operate it efficiently, you're able to observe, you're able to evaluate, and so on and so forth, right? And having capability to do that effectively is very, very important, because otherwise you'll end up spending a lot of time on these overheads and basically lose sight of your applications, or your end objective, right, which is basically meet your customers objectives or goals. Now, having said that, I think I just mentioned when I showed that big diagram in the beginning, right? Pipelines are very, very important, right? I've I've been involved like in throughout my career building developer tools and all that. It's very, very important to make sure like these are as smooth as possible, right? Things are automated. Um, Even with AI, right? Predictive AI, or nowadays people even call it legacy AI or traditional AI, which is interesting. It took a few years for ML ops to evolve, right? It didn't pop up immediately. People have spent a lot of time. I myself invested like more than a couple of hours, years, going through various options, iterating what's working, what's not, and I don't even think like we like reached a factory model of like saying, oh, this is the pipeline, right? We know the considerations. Now with Gen AI, like you don't have to reinvent the wheel, right? Of course, Gen AI brings in a lot of challenges, right, compared to your predictive AI. Gen AI changed a few things. It has introduced new challenges. Again, you don't have to start from scratch with it. You can use predictive AI approaches, in terms of ML ops. If you really look at it generically, right, the core objectives of ML ops for predictive AI and generative AI are kind of same. However, I mean, there are some unique challenges, right, with Gen AI. One thing is generative models are huge, especially foundational models with big infrastructure needs. Now, you don't have to do the training that you used to do in predictive AI, right? So that's a good thing. They need a lot of customization and tuning, right? It's not, and I'll talk in detail in the next slide, right? It's not about train, evaluation, and serve, right? There are even multiple layers, and you have to think about all those and see like how you're evaluating every phase, and how you can optimize. It needs obviously continuous evaluation and monitoring. And the other important thing is once they go from this, I don't want to kind of say it's that simple, but when you go from a POC hello world-ish, right, application, even if it's bigger, right, um, you have to think about connecting to enterprise system, line of business systems, right? Like again, all these extensions and uh, reinforcement learning, or whatever. There are so many layers that you want to leverage, and so on. That basically kind of expands the pipeline in certain sense, that uh, unlike a traditional model where you have just train, eval, and what do you call serve, this kind of introduces multiple elements, right? So compared to predictive AI, as I said, you don't need massive data or spend massive cycles to train, because the foundation model come trained. However, discovering, experimenting, and selecting foundation models will be important, right? And there are tools that Vertex offers. Each foundation models, responds to prompts in unique ways, and the results might be different. So you have to evaluate them, right? Try out a number of times, right, to kind of get that right, and kind of create a library of prompts and so on and so forth. You may use tools such as Model Garden, Gen AI Studio, and Prompt Gallery from Vertex AI for this purpose. It covers first party and OSS models, as we discussed. Now, while you don't train the models right from scratch, you tune the model too, right? Again, unless you're going in for like something very simple, right? One shot, zero shot, few shot prompts. So for that training, and tuning, right? There's a layer. right? And then you might have to not just use one approach, you might have to use multiple approaches. And that's where orchestration comes into picture, right? With orchestration, you can have uh, use these multiple frameworks and create these flows, right? And understand, like, how the sequence flows, how you validate these. I think some of these were covered by Adnan earlier. And then you need to curate the data. You have to augment data sets, right? That's kind of fundamental, right? It spans across the pipeline. On top of that, you have governance of both data and artifact, right? This is where your tuning pipeline, adapter layers, embeddings, lineage tracking, recitation checks, grounding maybe, they all kind of come, right? And then, yes, you kind of deploy, right? You distill those. Again, you use multiple models, right? The one in the blue, some of these Adnan covered earlier. And then you kind of prompt and predict. Now, you could also, as I mentioned earlier, right, if you don't require all that complexity, and if the use case is simple, you can kind of, you see the top line, right? Top blue line, you can discover and experiment with the model and straight away get into prompting and predicting, right? You can have your application invoke the API, just pass through. But more often than not, it's not that simple, right? There are multiple layers. Connection, right, is important, especially for large enterprise applications, because it's not public internet data, right? It's not like your all these chat applications, right? ChatGPT and Bard, where you could answer questions and all, right? Like consumer type applications, which is fine. But for customers in enterprises, right, they need to act on their data, right? So they need to retrieve the data. So for that, you could use, connectors. You could use embeddings with VectorDB, right, and have that VectorDB hosted in their instance, in customer's instance, and so on and so forth. So the bottom line, right, as you can see it on the top, the evaluation and monitoring spans across, right, the pipeline, and that's important. And getting that right basically means you have a trustworthy model that scales and meets your customer demands. So as we saw, right, given the evaluation is so broad now and spans the entire pipeline, it's not a solved problem, because there are multiple challenges, right? One is lack of data. Unlike predictive AI, we don't get started with humongous amount of training data, right? We just use these prompt approaches, as I mentioned earlier. Without the data, it's not possible to say how generated data looks like and kind of compare, right? We'll kind of go through with some approaches in the following slides. Second challenge is metrics, right? Unlike traditional AI or predictive AI, you don't have like these defined metrics, right, that talk about accuracy, recall, all those things, right? Area under curve. There are a bunch of metrics in predictive AI. You don't have it in generated AI. I mean, there are a few, but the challenge is very different, right? It's not like, oh, you're not predicting about the sales of a product, in particular time of the year, or for particular demographics, right? You're talking about summarization, generation, image creation. These kind of get very they all get it depends on person's preferences, their understanding, right? There's no universal thing, right? You can't say, like, this is the gold standard, right? Because it varies. And then finally, there's a large decision space. What I mean is, the evaluation, as we saw from the previous diagram, right? There's so many points we have to evaluate, right? Like, oh, did I tune it right? Oh, did I select the right model? Oh, did I serve it well? Oh, did I scale it well? Like, I'm using right tools or technologies. I'm getting the latest data or not, right? What if the data is stale? What if the data is biased? Like, how am I doing safety checks? All those things, right? They are very important. Let's look through some of these details, right? This is kind of a flow, right? You start with a model, understand basic performance and efficiency and cost, right? And then you use variety of tuning methods. Again, Adnan mentioned some of these, and evaluate the tuned performance. And then you distill the model, right, to get right price performance trade-off, because that's important too. Um, and evaluation does not necessarily end with performance, right? Just because you get consistent results, with a less latency, that's not end all be all. You need to evaluate a model if it's trustworthy, right? Whoever is using these applications that are leveraging these models, there's a big element of trust, right? And with generative AI, it's very, very fundamental, right? How do you know that the model is not hallucinating? Again, use all those techniques and all, right? But still, you have to continuously and judiciously, consciously monitor all these things. So from that perspective, right, there are three building blocks, if from at least from Vertex, right, for GenAI evaluation, and thereby the applications that are built on that. One is automated metrics, right? So we have a service for this. This has been released recently. It kind of gives, I won't say like predictive AI, but at least it's more quantitative, right? Things like RUG and View, if you're familiar with these, right? These are numbers, right? If it's 0 to 1, if it's near 1 means I'm more confident, right? Let's say the summarization, right? The summarization is good, whatever. So it's more around that, and I'll go through that in detail. And then what we second thing what we have is, like, again, when you start evaluating these models, right? Some customers, like, you have multiple foundation models that you want to kind of dynamically change, right? Again, this is not a very usual use case, but at least from an evaluation perspective, you might have that kind of situation, right? Then it makes it easy to compare two models. Again, we'll go through it. And then third point is, how do you check the robustness, right, of your safety bias? The model, as I mentioned earlier, right, it should be trustworthy. So we should use safety bias score and make sure that the safety filters are robust. Let's look at these in a little more detail. So this is the automated metrics are similar to the metrics we use for predictive AI, as I mentioned earlier, right? So the inputs that you get are the model and reference data sets. So different data sets are like the prompt and output combinations, right, that you think are right, and then you kind of compare that with the output, right? So it kind of creates a comparison, right? And then you have a metric that ranges from 0 to 1. And then basically you have summarization metrics, right? Basically the RUG family that you can leverage. I'll skip this. I think we're short on time, but suffice to say, like, these are most commonly used metrics. I mean, there are still a few more under kind of evolving, but as of now, I think I see a lot of developers and customers use these metrics. Then I'll touch upon auto side by side. See, metrics are important, right? But they don't capture all the nuances, human preference and evaluation, right? Because it's very preference driven, right? Whole GenAI thing. So comparing like text with one with other may not work. So in this case, right? So basically, what happens is you have two models and prompt, and then compare two models by a third model, which is called an arbiter model, right? That kind of plays a role of human judging the output, right? And then you kind of get what is called as a win rate, right? It says, oh, model A is like winning by 90%, model B is 10%, right? And then you kind of select model A as your option. You can also put human in the loop, because a lot of times people think like, what should I do? How can I trust the model? So you can use human in the loop. Before this, so the other last thing I want to touch upon is the safety bias evaluation, right? So there are tools that would automatically tell, what's the robustness of the filters that you have. It gives you a nice tabularized view, right? And says like, for each of these attribute, what's the kind of confidence level. There is a detailed demo in the next in one of the next videos. I think I've linked it in the reference section. Please feel free to look at it. It's pretty interesting. So with that, I invite Adnan to take over the security topic and bring the session to close. Over to you, Adnan.
Thanks, Maruti, again. So folks, in this section, we'll touch on trust and security issues for your application. First, let's look at some of the top concerns that we are hearing about around AI, including both predictive and generative AI. Security and privacy are top of the list, no surprises there. But as we saw, bias that can sometimes seep into your LLMs or GenAI solutions need to be addressed in some ways, and it has to be somewhat deterministic so that you're sure and confident that your solutions are not going to inject or introduce any bias in the responses that you are generating. Transparency and accountability helps with showing the lineage, the trails, and the explainability of your LLM's internal functions. So we are confident, both as a developers and as end users, that the responses that we are getting are based on some LLM thought process, and be able to surface that. Governments, regulatory agencies are also thinking about these things, and they are coming up with their regulations and compliance regimes. So that's something that you kind of want to keep an eye to educate yourself, so you can then build or adapt your applications around those requirements. GenAI or any AI application requires a lot of compute and infrastructure, as Maruti touched on, which has a direct impact on environment as well. So being able to, or being conscious about that, is going to be helpful as well. On the right-hand side of the slide, I'm shown some of our ways to address these top concerns. So responsible AI is our framework that addresses these concerns that are called out. It's our guiding principles, it's our thought model, it's the steps and actions that we are taking in our products and other places where we are ensuring that issues of security, privacy, bias are being addressed. We are also working with regulatory agencies, governments, and industries to understand their concerns and be able to educate and collaborate with them to address those concerns. And we have made public ESG commitments that we are providing regular updates on, and how our data centers, our infrastructure, are trying to neutralize their carbon impact. So given these concerns, the thing that you want to take away is that when you are designing and architecting your application, you want to be able to identify risks around trust and security and have some mitigation strategies for those risks. So essentially, building a threat model in a way for your GenAI application and having mitigation solutions for those threats. Some of the threats or examples of those threats or concerns are listed on the slide, and we are also suggesting some of the mitigation strategies. As you just saw from Maruti's presentation earlier, that we are rolling out some native capabilities, tool chains, such as model evaluations, automated matrices, bias evaluations, providing safety attributes and controls as parameters that you can specify in your applications to be able to control the behavior of your LLM to ensure that it's not hallucinating or going off the tracks. I will talk about two of such risks that you need to keep in mind. First one is sensitive data protection, in which essentially during training and inference of your LLMs, you want to make sure that sensitive data such as personal information is protected. Good thing is sensitive data protection is not a unique problem for GenAI. It's been around for some time, and there are solution products and services available. Google Cloud does offer sensitive data protection that you can consider if you are looking for one. The other risk that is fairly common is called prompt injection, where user can inject certain instructions or text in prompt that can then incorrectly guide LLM, or someone can try to exfiltrate data that isn't meant for them. There are various ways and patterns that are emerging on how to address this. It's still early days, but the way we are thinking about it, at least one of them, is that during prompt input processing, you can look for malicious text in your prompt using data exfiltration services like Cloud DLP that Google offers. Once you detect malicious text, you may want to filter it out of your prompt, and you can use an LLM to do that filtering for you. And finally, as we learned in embedding, we can use similarity scores to be able to compare incoming prompt with existing known prompt injection examples or attempts either within your organization or available in public. And then you can apply same techniques once you have the response and before it is shared with end user to make sure nothing in the response is unwanted. So with that, a quick intro or view into security architecture within Google Cloud for GenAI. Google Parameter is where you operate, is where you provision your resources, where you host your data, where you control the access points, and Google services through endpoints shown in blue, such as tuned adapter layers or large foundation models that your applications can then interact with. And just to close out on that, once you bring your data to our cloud to build your GenAI applications, you have complete control over your data, where it's hosted, how it's accessed, and how it is protected. And we stand by these commitments by abiding to regulatory compliances such as GDPR, FedRAMP, and so on. So with that, we are at close, but hopefully we got some insights that are helpful in your GenAI application journey. We will take some questions, but really quickly, the next session that is starting in a few minutes will go into an application development for GenAI. Thank you, everybody. That are hosting these reference architecture. And this webinar has few blogs and reference implementations as well. Do we have any LLM ops services from Google? Maruti, did you want to take that?
Yeah, I think, it's not like, a full pipeline, right? As I mentioned, there are services that cover aspects of that. This is a very interesting space. Keep watching. There could be some announcements going on in future, right? I would view this as as an extended pipeline, right, which covers both of these. So yeah, please do watch out for the space. I think there was another question on functions. I think as mentioned, so extensions, right, kind of do something similar and more, right? It's kind of a different perspective, but yeah, I think watch out for extensions. And as Adnan mentioned, we had a talk in Next that shares our vision of extensions. I think it would be a good watch, and keep watching on this, right? Again, the point I want to kind of add is technology is evolving at a rapid pace. There's a lot of new services coming up, almost like a weekly basis from us. Please do kind of watch out. Google Blogs are a great source, right, where you'll get updated information. And feel free to kind of contact us, communicate us, via communities. That's a great place. You have questions, you can continuously engage with us.
With
thank
that,
you so much.
I think we are on time, but I'll quickly take a couple more. There's a question about when are some of these mechanisms integrated in Vertex AI. Most of the mechanisms that we showcased in this deck or presentation are already part of Vertex AI, so feel free to check them out. And yeah, I think that's probably the gist of the question. So thank you. Thanks again. Hopefully this was helpful.
Yeah, we have the next one following up very soon.
Take care, guys.
Hi everyone, welcome to our Generative AI Hands-On Workshop. We're excited to have you join us today. My name is Ebru. I'm a customer engineer on Google Cloud, specializing in data and AI. And today I'm here as one of the presenters for the workshop. I also have two of my friends, Muthu and Haran, with me. And Muthu, Haran, do you want to introduce yourself?
Yeah, sure. Thanks, Ebru. Good morning, good afternoon, good evening, everyone. I'm Muthu Munogaran, based in Pittsburgh, Pennsylvania. Currently, I work as a senior customer engineer at Google Cloud. With over 18 years in the IT industry, I specialize in cloud solution architecture, and my expertise includes leading cloud migration initiatives and driving AI ML projects across diverse industries. I'm thrilled to be here. Thanks for joining us today. Over to you, Aaron.
Hi, everyone. Thanks for joining today. My name is Haran, and I'm a customer engineer on data and AI. I'm very excited to be here today. Let's have some fun today. Back to you, Ebru.
Awesome. Thank you. All right. I will open the session by introducing you to Firebase on Google Cloud and get you familiar with the environment. Muthu will introduce you to Palm extension in Firebase and will give you a walkthrough of the final application you're going to create during the lab. And then Haran is going to take it over and guide you through the lab, where we're going to spend most of our time today. So let's get started. All right. When we choose the use case for this workshop, we made sure it was relevant to the needs of the market and had a real world use. One thing we all agreed on this, that applications are taking over the most digital experiences, whether it's a web application or mobile app. 90% of all mobile time spent in applications, and 49% of these users are opening an app more than 11 times a day. This means that if you want to reach your target audience, you need to have an application. Apps are more engaging because you can provide more personalized experience. This is why users spend so much time in apps, right? The user base for applications is growing for sure. As the number of users increases, so does the demand for engaging applications. Generative AI is opening up new opportunities for developers to create innovative applications. And this is exactly what we're going to do today. By using Google's strong generative AI model APIs like Palm API, we're going to create a chatbot that interacts with users in a natural way. If you take your learnings from today and apply it to your applications, you can improve the user experience and make your applications more sticky, basically more enjoyable. Firebase is Google's unified application development platform. It's not just Android, I have to say. You can integrate Firebase with iOS, Android, and web applications, as well as a variety of gaming platforms. Since Firebase launched in 2016, we are seeing an exponential growth of Firebase developers, both from large enterprises and small, nimble startups across all verticals. Firebase powers over 3 million developers, 2.3 million active apps serving 7 billion end users across various web and mobile apps. And you'll even find Firebase used in top grossing apps for Android and iOS. Well, honest question I have here. Why do you need Firebase? Building an application requires pretty extensive knowledge of different tools. And thinking loud here, if I am building a chatbot application with you today, I'm going to need a user authentication, a database, a server, and like how do I create and maintain that server, right? I wonder if I'm going to need web hosting or file storage. That's exactly where Firebase comes in. It provides a set of tools and services for building, testing, and deploying mobile applications. It is designed to make it easier for developers to build high-quality, scalable, and secure applications. And I want to highlight some of these tools and features I have been talking about. The first one is Firestore. It's a NoSQL database service that gives us the ability to add database functionality to our applications. Normally, you have to make multiple server endpoints to read data or make changes to the data. With Firestore and Firebase integration, you can make these changes directly from inside your client-side code if you choose to. You have cloud messaging service that allows you to send push notifications to users of your apps. The Firebase user authentication provides developers with a simple way to authenticate users of their apps. It supports a variety of authentication methods. You can use email and password, social login, or phone number verification. You also have Cloud Functions, which is a serverless compute infrastructure for event-driven programming. My favorite one as a data analyst, Firebase supports data exports to BigQuery directly from several Firebase products and Google Analytics, which you can turn on easily within your application. And exporting that data into BigQuery is one of the easiest ways to take more control of your app's data. Sometimes hear that developers are a bit confused about the Firebase versus Google Cloud. Google Cloud is a suite of cloud computing and data management service and all the infrastructure that comes along with those type of services. And Firebase is a developer environment built on top of Google Cloud. As a matter of fact, both Firebase and Google Cloud utilize the same exact project and organization. So when you hear of a Firebase project during the workshop, it's really just a Google Cloud project behind the scenes. It just has Firebase enabled for it, meaning it can use Firebase APIs and provide centralized location for managing all your Firebase project, including your apps, databases, and storage. Firebase offers nearly 21 products that supports developers and businesses across the life cycle of an app. And those products roughly align with 3 core challenges that app developers face: building a backend, ensuring app quality, engaging end users. Firebase and its products are just one piece within the large Google ecosystem. If you ever get lost, I'd like to share this developer cheat sheet with you to reference. I do have the QR code that you can scan and go. I also have the link, and I will just show you very quickly that it is a cheat sheet for developers where you can see all the cloud services and what they are for. You have for example, the Vertex AI Workbench. It's a Jupyter-based environment for data science. And what is Cloud Vision? What is Dialogflow? Contact Center AI. So you can actually go through this map and understand the Google Cloud services available to you. Going back to the slides. Now I'm going to talk just briefly about the Firebase extension and what they're for, just to give you an understanding of it. Firebase extensions are prepackaged solutions that provide extended functionality to your app, like, for example, image resizing. They're configurable, easily deployable, and work with Firebase and other Google Cloud Platform products. All you have to do is to install and configure the extension. The suits your use case, and then the extension does the rest of the work. At its core, an extension is a package of code that performs a task whenever a specific event occurs within your app or project. And the awesome part is that after installing and configuring your extension, Firebase automatically scales up and down computing resources to match the needs of your application. There's no need to worry about server configuration, provisioning new servers, or decommissioning old ones. Also, if there's any changes in SDKs and a new version of an extension is released, you simply click update in the console and you're on the latest version. So now I'm going to pass the flag over to Muthu, who is going to take all you heard from me and tie it all together to generative AI and the application we are going to build during the workshop.
Thank you so much, Hebrew, for setting the stage. That was a nice presentation. All right, so now let's discuss about POM API. Before I talk about POM API, let me give a quick explanation of what is POM. POM stands for Pathway Language Model. So it is a transformer-based large neural network language model developed by Google AI. The initial version of POM was announced back in April 2022. On May 2023, a new iteration was announced called POM 2. Okay, what is PaLM 2? PaLM 2 is our next generation LLM that builds on Google's legacy of breakthrough research in machine learning and responsible AI. And PaLM 2 excels at advanced reasoning tasks, including code and math, classification, and question and answering, and translation with multilingual proficiency, and also natural language generation better than our previous LLMs, including PaLM. And PaLM 2 can accomplish various tasks because of the way it was built, bringing together three distinct research advancements in the LLM. The first advancement in PaLM 2 is use of compute optimal scaling to scale the model size and the training data set size in proportion to each other. The second advancement in PaLM 2 is improvement in dataset mixture. In the previous LLMs like PaLM, we used pre-training datasets that are mostly English-only text. But in PaLM 2, we have improved corpus of data with more multilingual and diverse pre-training mixtures, which includes hundreds of human and programming languages, mathematical equations, scientific papers, and web pages. And the third advancement in PaLM 2 as an improved model architecture and objective. So we continue to implement the latest version of PaLM 2 in all our generative AI tools, which includes the PaLM API and also the BARD. So currently the PaLM API is comprised of three endpoints. The first is chat, second is text, and third is embedding. The chat endpoint allows developers to build chat applications that can communicate naturally and very smartly with the users. It can manage multiple rounds of conversation, keep track of context and memory, and switch between topics and goals. The text endpoint lets the developer build applications that can generate high quality text for different purposes. So it can deal with complex prompts and instructions, such as creating an articles or writing an email or summarizing a big paragraph. The third endpoint, embeddings, allows the developers to build applications that can produce embeddings for words, phrases, and sentences, and it can also help with NLP tasks such as semantic search and text classification. As Ebru mentioned, Firebase is an app development platform backed by Google and trusted by millions of developers around the world. So if you're a Firebase developer interested in using the PaLM API to build a natural language application, the good news is there are 5 Firebase extensions powered by PaLM API currently available in the Firebase marketplace to make your life easier. So let's take a quick moment to talk about those Firebase extensions briefly. The first is the chatbot with the PaLM API Firebase extension. This enables the developers to create an interactive conversation between the users and the LLM through the PaLM API. And under the hoods, it uses the Firestore as a collection database. The second extension is called Summarization Text Firebase extension. It's designed to generate summaries for various applications. This extension is a handy way for developers to use PaLM API as easy as possible. And in my opinion, it's a very good place to get started. And some of the variety use cases this extension can include is summarizing customer feedback, or if you want to abstract long articles, or if you are looking for condensing and user-generated content. The third extension is called Language Task. This extension enables developers to perform diverse text-based tasks such as translation or classification, summarization, or even named entity recognition. Or if you want to create some creative text generations, some of the examples like you want to predict a star rating on a collection of product reviews, or if you're looking for classifying customer feedback based on their sentiment, and analyze if it is positive or negative or neutral. Or if you're looking for summarizing long articles, extract the name entities from text, or writing a poem, or writing a code as well. And the last two extensions are, one is semantic search with Vertex AI, which enables developers to perform search for semantically similar text and the documents which are stored in the Firestore using the PaLM API and the Vertex AI matching engine. And the last extension is called Call PaLM API Securely. It offers secure API endpoints. It is protected by app checks, which allows developers to interact with PaLM API from their Firebase app. By using these extensions, developers can develop a seamless integration between the PaLM API and the Firebase application. All right, here is a high-level architecture of how Firebase extension and the PaLM API are integrated. If you look at the follow my arrow, the client sends a prompt to the app that are hosted in the Firebase hosting. The prompt is then written to a Firestore collection document. Then the Fire extension reads the document. That is where the magic happens. The Fire extension calls the PaLM API that gets the response using your GCP cloud function. And then the response is written back to the Firestore collection document. And then the response is sent back to the hosting and back to the client application. That's the high-level view of how this extension integrates with the PaLM API. All right, enough of slides. So let's look at a demonstration. So what I'm going to do as part of a demo is you'll witness the Firebase extension for language task in action using a sample application called Reviewly app. So let's imagine a t-shirt company is flooded with lengthy of reviews for one of their popular products, and they are unsure about their overall rating. So to address this, the Reviewly web app uses the PaLM API extension using the language task to summarize each review and analyze each review for sentiment, and also provide a star rating based on the positive or negative or neutral review, and use all the reviews to decide overall rating of the product. So now I'm sharing my browser where I have logged into the console for the Firebase, and I have a project called AI Extension Code Lab. So let me go into that code lab now. And if you watch my mouse, I am pointing to the left side where I'm going to click on the extensions. So this is where once you install the extension, you will see it under the extensions tab. And at this moment, I have only installed one extension, that is language task with PaLM API. So let's explore that. So if I click on manage, I'll be able to see what are all the parameters I can fine tune. So as you can see here, based on your use case, you can pick and choose the parameters that you would like to as part of your application. So in my situation, I have used the Vertex AI, the PaLM API from Vertex. Or if you want to use the generative language AI for developers, you can also pick that option. And I'm using a collection named bot. And with the input parameter for the document is called input, and the response will be saved in text. And there is a function, as I said in my previous slide, so that runs in the US Central region. That is where the magic happens. And I'm using text Bison. And there are some couple of parameters that lets you to fine tune this model. So in terms of like temperature, so if you want to control the randomness of the output, so it ranges from 0 to 1, the value closer to 1 produce more varied responses. When the value is closer to 0, you will not get some surprises from the model. It'll be shorter responses. So I'm not going to go over each and every parameter. So you can over this question mark, and you will see all the explanation, and also a pretty good documentation link are available in each extension itself. And here is the API and the resources that's being used. So as I said, there is a cloud function that is being deployed as part of this extension. So the beauty of this extension is you don't really need to write all this code. So Google has taken care of writing this code and managing this. So as a developer, you just need to install this extension and start working on your app. All right, so let me jump into the app itself. And as you can see, I've just split my screen into two just to show how the Firestore gets updated when I am accessing my Reviewly app. So before I do that, I just want to quickly run a quick test. So let's go into the document, create a random document here, and say input. And then I'll say the value as tell me about